Hello everyone in AP Environmental Science. I am at a conference in Salt Lake this week, and so I am coming to you in the screencast. I will be recording a few of these screencasts because my time is limited to 15 minutes per screencast. But anyway, I'm going to explain to you Land and Water Use Section 4, and this one is on pests today. After this screencast, then you will take the quiz, and I will get your quiz scores when I get back, and we'll do the coin toss for note checks when I get back as well. So let's dive right into this. First of all, let's take a look at this first thing right here. This is a locust. Okay, so it looks like a grasshopper. This is an insect that lives in the Middle East and also in northern Africa, among other areas. And normally these guys don't really achieve very high populations because limited food availability and predation keeps their numbers in check. Occasionally, however, there will be ample rain in certain areas, or during certain times there will be ample rain in these areas, and with more rain, vegetation takes advantage of that, and the plants start to grow very rapidly. And now the locusts have plenty of food, and they will grow almost exponentially for a while. So your book talked about it. At first, it gave a Bible verse about how Moses, in the book of Exodus, announced, as he was trying to get the Pharaoh to let his Israelites go, he announced that there would be a plague of locusts upon the land. So we have also seen these plagues in modern times. Your book gets into how they can undergo explosive population growth, forming swarms of 80 million locusts per square kilometer. So that's 300 million per square, or not 300 million, but 30 million per square mile. So can you imagine how many locusts that would be in just a gigantic swarm of these creatures? So they would just be eating up all this newly grown vegetation. And one time, in modern times, your book goes into how in October of 2004, 7 to 10 million acres, that would be 3 to 4 million hectares of land in a band across Africa was covered with the migratory locust. So this was the map of where they were seriously doing damage is in these green and yellow areas. So normally they live in the green areas called the recession areas. But in 2004 they were able to grow so much, there was so much rain that year that there was a boom in the vegetation, and they were able to invade other areas and just wipe out crops and devastate harvests that farmers had worked hard to cultivate and prepare for the coming harvest. So what happened, this was tracked by modern equipment. It was tracked by satellite imagery, so kind of a cool thing with satellite imagery. That was the locust plague of 2004. Not a very good thing for those farmers. So today, we're going to talk about pest control. These are the main things we're going to overview. We're going to look at the need for pest control, also the promises and problems of the chemical approach. So I think actually this part we're going to skip, and we will get back to that later this year. If I could find my keys, there we go. We're going to look at alternative pest control methods, socioeconomic issues, and I think actually we're going to cover these just two main topics, so let me get rid of that one. And we do policies in another unit. Here we're going to focus on the need for pest control in our land and water use unit and methods, alternative methods for pest control. Okay, so let's get into it. First of all, the need for pest control. A pest is defined as anything that has a negative consequence, rather, on human health or on human economics. It can also be defined as an organism that is noxious or destructive or troublesome. Okay, so in your book, there were a few pests. Let me pause for a second and find out where I'm going to be at. Okay, so here are some examples from your book. So I'm just bringing up some images. This one would be the termite, and termites can eat wood and damage homes. Here we have fire ants, insects that are invasive, and these are stinging ants. Okay, another one would be, the mosquito. Can carry disease, and also, apart from being just annoying, it carries diseases like West Nile virus. And this one was from your book, the midfly. And let's see. They don't have to be animals or just insects. They can be plants like crabgrass. Crabgrass can be particularly annoying in your lawn. It grows like crazy and it chokes out your normal grass. Okay, so those are some examples of pests. These are the purposes of pest control. We depend on food that we raise, and if insects and other pests are eating our food, then we have less food to eat, or if they spoil our food, we have less food to eat. Therefore, it's important to control the amount of pests in our food. It's important so that we can protect our health, because pests can spread diseases, and the convenience of it. Who wants to live in a mosquito-infested world? This is pesticide use in the United States. This graph goes from 1964 to 2001. The brown would indicate non-agriculture use of pesticides. We have mosquito abatement programs here in Weber County. So the Weber County government is responsible for spraying areas that typically are high for mosquito breeding. So that would be out west from where we are at, near the Great Salt Lake in Standing Water. And they spray during the spring and during the summer when mosquitoes are most likely to hatch and live. So that mosquito abatement, not only does it, the pesticide that they use to kill those mosquitoes, not only does that make it nice for us so we don't have so many mosquitoes, but it also makes it so that it reduces the chance of spreading diseases like West Nile virus through mosquitoes. Now, these are agricultural. The green line is our agricultural uses of pesticides. So obviously for agricultural uses, that is to ensure that we have food and that our crops are maintained and not eaten by these pests so that we have enough for us. Okay, now notice that it was really high. The highest peaks are in the late 70s, and then they came down, and then there was another peak in the 90s, and then they've been going down as well. They're still not down to pre-1964 levels, and we will talk about this, I think, at a later time. We'll talk about a scientist named Rachel Carson and what she did to expose the harms of using active chemical pesticides like DDT. And unfortunately, she died of cancer as a result of poisoning from pesticide chemicals like DDT. She had breast cancer and she passed away. But she shed a light in the public eye with her book Silent Spring on the dangers of chemical pesticides and how they could harm humans even, and other species. And we'll get into that more this year. Good book to read, Silent Spring by Rachel Carson. Alright, let me take a look at my notes and how much time I've got. Alright, there are 3 different philosophies of pest control. First of all, there's chemical pest control. So this is like the mosquito abatement program that we have in Weber County, where chemicals are sprayed to kill large numbers of the pest. This gives more of a short-term protection because the chemical just kills the pest. It doesn't do anything about allowing the pest usually is able to reproduce well, the survivors, and there are environmental and health consequences of using these chemical pesticides because some of the same pesticides used on pests are harmful to humans in large quantities. Okay, there's ecological pest management. This is based on the life cycle and ecology of the pest. So the agent may be an organism or a chemical. A specific to pest ecological philosophy is pest control is using a chemical that is specific to the pest or manipulating just a small part of the ecosystem. That one is distinct from traditional chemical treatment where you would just spray a large area without being specific. So it might kill the pest, but it would also probably kill some non-pest species. So the ecological philosophy targets the pest and emphasizes protection from the pest. The last type is integrated pest management. So integrated pest management looks at all suitable methods, chemical and ecological, and it looks at long-term management of pest populations with minimal environmental impact. And this is where I'm going to pause. I am running out of time for part 1, and I will see you in a few seconds for part 2.